G'day folks, it's Rob here, and in this week's clip we're going to be taking a look at a bit of an aquaponic system design. I had a chap hit me up in one of the older radial flow filter clips, Pat. G'day Pat. He asked for my advice on setting up his own little backyard aquaponic system, so I thought we'd have a bit of a look at some diagrams I've knocked together and a few explanations on some components and a few tweaks that I'd do to the system. Before we have a good gander at this system, it'd be great if you could hit that little subscribe button down there and then click on the bell icon when it appears, and you'll be sent notifications when I upload the future clips that will be looking at different component builds and different aspects of setting up and running an aquaponic system. So Pat's given me a bit of a rundown on the components he'd like to add to the system. To start off with, there's going to be an IBC fish tank, so 1,000 litres, 260-ish gallons worth of fish tank. Then he wants a solids filter, a radial flow filter, and then from there the water is going to run out to some grow beds. He's also a little bit up in the air as to whether the water should flow back to a sump tank or a fish tank. So because he wants an IBC media bed, I've suggested that Pat chop the top off an IBC, flip it over, that'll become your media bed, and then the rest of the IBC container you can use below as your sump tank. And if Pat decides to expand down the road and include some more media beds, some flood and drain beds, there'll be that extra volume in the sump tank to be able to handle that. Now there's a few ways you can plumb up your aquaponic system, and there's a few different acronyms floating around the interwebs, but today's system is going to be plumbed up split flow style. So what that means is basically the pump is bringing the water up from the sump tank. It is splitting the flow to two separate loops. One loop is the fish loop and the second loop is the grow bed loop. I will be doing a clip further on down the line that does explain the differences between the different ways you can plumb up the systems, so keep an eye out for that if you're interested in checking it out. So the best place, I suppose, to start looking at this system would be to trace the water from the pump in the sump tank. So to begin with, the pump itself, I'd recommend Pat goes with a 6,000 to 8,000 litre per hour pump, mainly because you do need that little bit extra volume movement per hour to make allowance for the head height of the water being pumped up to the grow beds in the fish tank, and also the walls of the pipe can slow the flow down, and you've also got a couple of twists and bends and different fittings in there as well. So it does pay to go a little bit over the top with the pump. So once the water is picked up by the pump, it runs through a line that has a T or a Y fitting in it, and that's what splits the flow between the two different loops. Following the first loop, the water is pumped through the pipe or hose up into the fish tank, where the accepted rule of thumb is to have an incoming flow rate that is the same volume per hour as the fish tank volume is. I personally would prefer to run more than that. In our system here, I'm running around about 2,000 litres an hour, or double the tank volume every hour. Now into the fish tank we also have an air line. This is what will add movement to the water and help dissolve oxygen into the water. Another good rule of thumb there is pretty much all the same as the water, at least the volume of the fish tank itself in air pumped through there every hour. So at least 1,000 litres or 260 gallons of air coming into the fish tank every hour just to keep those fish happy. Now for this system, I've suggested maybe a 4,500 litre an hour air compressor, and that will give enough air into the fish tank and also to look after a few other needs in the rest of the system. Now back to the water in the fish tank. As the water enters the fish tank, it displaces the water that's already in there up through the base of the solids lifting outlet. So the solids lifting outlet consists of a 2-inch or a 50mm pipe that runs from the base of the tank where it collects the fallen fish waste as well as any uneaten fish food, and delivers it up through the pipe to a sideways sitting T-fitting connected to the top of it. A pipe is connected to the port 90 degrees from the collection pipe, and that runs it out through a uniseal that's been installed in the side of the tank wall out into the radial flow filter. The skyward facing port in the T-fitting is left open, and what that does is it prevents the siphon from initiating from all the water flowing out of the system, basically ensuring that you will always have some water in there for the fish even if the power goes out. As I mentioned before, the pipework comes out through a uniseal installed in the side of the tank wall and then down to the radial flow filter. In all my designs, I have a valve in between the fish tank solids lifting overflow and the filter itself, mainly because I can just turn it off whenever I want to clean the radial flow filter after I've turned off the pump into the fish tank, of course. So the water enters the filter via a standpipe and is redirected using a stilling well. That allows the water flow to slow down enough for the bulk of the solids to fall out and collect on the base of the filter. And all the clean water is then moved out through the outlet at the top of the filter, down another 2-inch or 50 ml pipe into the sump tank. So now we're back in the sump tank and we can trace out the second loop that flows through the other line in the Y fitting from the pump. That one there runs out to the grow beds and is controlled at the inlet of every grow bed by a valve. With the media bed, I'd set it up as a flood and drain as it provides extra air to the bacteria and the roots of the plants. Constant flow beds work well too. I just like the idea of having extra air available in the root zone for the bacteria and the roots. As for siphon types, I really do like the Bell siphons. I find them to be very reliable the way I make them. If you want to check out how I make them, you can click on that little link up there and that'll take you to the clip that shows you how they work as well as how I knock them together. Now the deep water culture bed has a valve that comes through and runs into a little filter sock. I've decided to use a little filter sock just to help keep out any of the fine little solids that do make it through the system, and you can just hose that out, you know, once or twice a week. If you're really concerned, you can set up a little canister filter like the one I set up for my mother's chop and flip aquaponics system, and they're great at collecting all those little fine solids out. As for the flow rate into the deep water culture beds, they do like a fairly slow one, so a retention time of 1 to 4 hours. Now in this bed here, it's roughly around about 600 litres, so Pat would be looking at a maximum flow rate in there of around about 600 litres an hour. Slightly slower wouldn't hurt it at all. As for the rafts themselves, I prefer to use purpose-made, food-safe grow rafts. You can use the extruded foam insulation over in the States. You're going to have to double check this though. I think there is at least one brand that doesn't have any fire retardant in it. I rang up a manufacturer here in Australia and he told me that they use a fire retardant in there. So I decided to err on the side of caution and I decided not to use it in my system. You've got to make your own informed decision though. So if you're in Australia, ring up the manufacturer, see if you can find someone who has a product that's safe. The guy that I spoke to said he wouldn't use it in any system that he built. So for that reason, I'm sticking with the purpose-made rafts. So underneath the rafts now, and the roots of the plants. Now, I did mention before taking the solids out. The reason being is that the solids accumulating on the roots can inhibit the uptake of nutrients, but they can also promote some diseases and infections of the roots themselves. So it's best to remove them when you can. It is a good idea to have well oxygenated water around the roots of the plant. So I've included a series of air stones in there as well. They'll also help give oxygen to the plants themselves through the roots and also keep some infections and diseases away. And from the other end of the raft bed, I've just got another little outlet pipe, just a 1-inch or 25 mil jobby that runs straight down into the sump tank itself. By the way, just looking at this grow bed layout, you don't need to run them in a line. You could have them running across the sump tank, so you can orientate them differently. It's just a good idea to have that sump tank in a central position just to make your plumbing easier. So this little system as it stands is a great little start, but I do think it needs some tweaking just to help it run a little bit more efficiently. First of all, we're going to look at the biofiltration requirements because it's basically going to dictate how many fish you can have in the system, and as a result, how much secondhand fish food excreted by the fish will be available as nutrients for the plants. So working out the stocking capacity of a small little backyard aquaponics system is relatively easy. So the standard 300mm or 1 foot deep IBC grow bed has the biofiltering capacity to handle the waste generated by 12 fish that you would like to grow out to 500 grams or 1 pound in weight. Now what I'd recommend Pat do is increase the depth of the grow bed to 400mm, allowing him to stock another 4 fish, and that'd still leave him with a very sizable 600 litre-ish sump that he could then add more flood and drain grow beds onto if he wants to down the track. So now we know how many fish we can stock in the system. We can roughly work out how much nutrients per square metre or per 10 3/4 square feet we have to feed the plants. So 50 grams is good for a lot of the salad greens and some of the herbs. The more nutrient hungry plants, the fruiting plants, your cucumbers, eggplants, tomatoes and whatnot, they will need closer to 100 grams worth of food per day, so they have enough nutrition to grow healthily. Now one of the problems here, and this is why these statements are very general, is the fish food that you will be using will vary from brand to brand and also from fish species to fish species. Not only that, the fish species themselves will take out different nutrients to other ones, so this is a very general rule of thumb. So to get 50 grams in there for those fish, just to look after one grow bed, 1 meter square grow bed, they need to be roughly around about 250 grams each. The fish will only be half grown at the time that they can supply enough nutrients for leafy greens, for just the media bed by itself. What we've got to consider is trying to beef up the number of fish in the system, and the easiest way I can see for us to do that is to add a standalone biofilter. I'd pretty much will recommend Pat get a moving bed biofilm reactor like we run in our system here. Our one has roughly 95 litres of the PEO3 biomedia. So 1 litre of this media has enough surface area to home the bacteria required to process the waste from a 500 gram or roughly 1 pound fish in our climate here. So it's a very good media to use. It's actually been designed for wastewater treatment, so it's pretty much what I would stick with. So if Pat added in 14 litres of this biomedia, he'd be able to stock another 14 fish, bringing it up to 30, and they should provide more than enough nutrients to run these 3 beds. I personally would up it to 20 because every bag of fish I've bought, there's always been a few extra added in there. So probably 20 litres would be enough to cover Pat if he ordered 30 fish. Now, as for the way that these biofilters work, the water comes in through the inlet at the base of the filter. I'd use a 200 litre filter, the same as the radial flow filter, and that will give a retention time of around about 6 minutes on a 2000 litre an hour flow rate. That will give the bacteria on the biomedia a lot of time to process that ammonia. In the filter as well, there's also an air source because bacteria need oxygen to perform the conversion of the ammonia to nitrite and then nitrate. It also helps to move the media around. One of the benefits to that is it knocks off any dead bacteria that is building up on the media, keeping it nice and clean and letting it run efficiently. So once the water's moved through the media and has gone out through the drain pipe, it flows down to the sump tank where it can start its journey again, either out to the fish tank or off to the grow bed side of the system. So there you go, Pat. I hope this clip has helped you out with the general layout. There's a lot more I could have put into it. I started off with around about 8 to 10 pages, but it would have made this clip a mini series. So I've cut it back down to the bare minimums. And what I will be doing over the coming months as I get the time is releasing clips on individual parts of the build. May not help you out, sorry, Pat. But things like clips on the radial flow filter, even a new clip on the solids lifting outlet, the fish tank flow rates, all those sorts of things. And when it comes to reworking our system here, I will actually be doing clips that walk you through step by step how I'm making each individual component so you get a better idea for yourself. And for you folks out there with more experience, the whole idea behind this system is to create a very basic system. The water flows around in 2 basic loops. I know there's other ways you can trick it out with dual drains and all the rest of it, but as a starter system, I think this is a good place to start. And as Pat and other people who may want to use some of these components, learn more about aquaponics, I'm sure if they're like the rest of us, they're going to tinker, and probably the system will evolve over the next 3 or 4 years. Once again, I would like to thank you all for coming along. I do hope you've enjoyed the clip, and don't forget to hit that subscribe button if you haven't done so already. So I'll pretty much will leave it there, folks. I do hope your gardens and aquaponic systems are booming, and I will catch you next clip. Cheers all, have a top one.